Hello guys, today as I am starting the new course distributed computing. So this is the introductory lecture of distributed computing. So let's start. These are the few recommended books. So if you want to study the distributed computing in a detail, so you can download it. What is distributed computing? Distributed computing is a model in which components of the software system are shared among multiple computers or nodes. Even though the software components may be spread out across multiple computers in multiple locations, they run as a one system. And the objective is to improve the performance. So distributed computing means the distribution of computers across the globe. So different computers or different nodes are connected, or we can say different nodes are shared for some goal, for some computational goal, and all the systems run as a one system. But it is not a one system, it is comprised of many subsystems. Why we adopt distributed computing? There are certain reasons that will be discussed laterly in a quite detail, but the main objective is to improve the performance. Sometimes the task performed by one processor is slower, or the one system is not efficient to execute one particular job. So we adopt a distributed computing environment. Either the single task is distributed or multiple tasks are distributed. So sorry, if we look to the task, so the larger task defined will be the job. So we can say that either one job is distributed among different nodes, or multiple jobs are distributed and assigned to some particular dedicated node. Look at this. We have different nodes. These are the three nodes connected to this server, and we have three nodes physically connected to this server, physically or through some local network. And these different nodes, these nodes and these nodes are connected through some global network, and this whole as a unit run for some one goal, for some one purpose, or we can say that the whole system run as a one system. But it is not one system, it is consist of subsystems. Distributed computing refers to two or more computer network together sharing the same computer work. Distributed network is mainly heterogeneous. There are two terms used, homogeneous and heterogeneous. This is distributed network is a heterogeneous in nature, in the sense that the processing nodes or computers and network topology. What is network topology? The style or the pattern adopted to interconnect different nodes using some network. So the fashion in which the different computers are connected is basically the topology. So different systems have different topologies, communication channels, operating system in different network which are widely distributed over the globe. So the property of distributed network is that mostly it is a heterogeneous. And we can say each node is autonomous or independent for executing the task. Or we can say every node is responsible for independent execution when run in isolation. But for some specific goal or computation, we create a distributed computing. The features of distributed computing is that there will be no common physical clock, or we can say no global clock. So this play an important role to introduce the element of distribution in a system and takes the responsibility to provide inherent asynchrony among the processor. This means if there is no one physical clock common to all the processor, so it will create asynchronous behavior. And remember that every subsystem of the distributed computing will have a physical clock. Each system when execute and work on some task will have a physical clock, but there will be no common clock. In distributed network, the nodes do not share a common physical clock. So we can say there is no physical clock, but there is created a logical clock which bring all the tasks together at the end. There is no shared memory, no common shared memory. So this means one subsystem cannot access other system data. Every system possesses its memory, physical memory, but there is no common shared memory. An important and key feature of distributed computing and message passing model of the communication is having no shared memory, which also infers the non-existing of common physical clock. Process in the distributed system obtains coherent view of the system, but in actual that view is partial view of the system. Like the logical clock, we have a coherent view of the system, but in actual there is that view is a partial of the system. This means there will be no shared memory, common memory, and geographical separation exists obviously. So the system may be connected through LAN or WAN, but if there is a separation is large, like one system is in one place and other is some other city or country, so it will be obviously connected with WAN, but it is not bound to WAN. So it is possible to make a network cluster of workstation present on LAN can be considered as a small distributed system. Autonomy and heterogeneity. Autonomy means the every component or every node will have independent characteristics that make it autonomous, and so that make it heterogeneous. The system is may become heterogeneous. But remember that the nodes cooperate each other. Although they are autonomous, independent, there is no physical clock, one clock, there is no shared memory. But the components coordinate each other by message passing, by cooperating with one another, by offering services or solving problem together. And this is the purpose. Like when we assign some job or some task to two persons, like we take example of persons, two persons. So tasks are distributed. Some tasks are assigned to person A, some to person B. Both persons are autonomous, have unique characteristics, but the end purpose is same. The goal is same, and they both work together in coordination and look like they are running as a one system, one person. The purpose was to improve the efficiency by dividing the tasks in two people. But if the goal is same and they work as a one system, so obviously they must have coordinate each other for problem solving. Terminology is used in distributed computing. Job is a bigger term as compared to task. So job is overall computing entity that need to be executed to solve a problem at the hand. There are different types of jobs depending upon the nature of computation or algorithm itself. And each job is then comprised of sub-jobs or tasks. So we define a granularity of the job or task. So it is simply the size of task is expressed as the granularity of the parallelism. The grain size of the parallel instruction is measure of the how much work each processor does compared to an elementary instruction execution time. It is equal to the number of serial instruction done within the task by one processor. Remember that there are two types of instructions going inside the distributed computing. One is a serial and one is a parallel. Parallel means the tasks are assigned to two different or multiple nodes. But if multiple tasks are assigned to single processor, so the single processor then execute that task or instruction in series. One by one, the task is performed by the node. So we define a granularity which shows how much task should be performed in a particular job by the whole system, and then how much tasks are to be assigned to each processor. Number of tasks can be different, and then what should be the size execution time of the particular task, minor task assigned to some processor. So there are different granularity measurements taken. One is a fine grain, medium grain, and coarse grain. Node is an entity that is capable of executing computing tasks. For example, processor unit within a computer system is the example of node. Task is logically discrete part of the overall processing job. Like we take example of our daily life employee job. So person is doing one job, for example teaching job, but inside teaching we are assigned different tasks. Each task is distributed over different processors or nodes connected through a network to work on each task to complete the job at the aim of minimizing the idle time. And topology is the way of arranging the nodes, the style, the fashion through which the arrangement style through which different nodes are connected through a network, or we can say the geometrical structure of the network is known as topology. And topology shows how the nodes will contribute their computational power toward the task. Lastly, we come to the overheads. Overhead measure the frequency of the communication among processors during execution. So this is the important property that processors will communicate, will coordinate, and coordination is basically the communication, providing services to each processor. and that is measured in terms of overheads. So during execution, processor communicate to each other for the completion of job as early as possible. So obviously communication overhead takes place. Three types of overheads. One is a bandwidth, latency, and response time. Bandwidth is actually the range of frequencies the system allows. So it measures the amount of data that can be transferred over the communication channel in finite period of time. It always plays a critical role for the system efficiency. And latency is the amount of time it takes for data packet to go from one place to another. So greater is the latency, less will be the efficiency. So efficiency is actually the performance. So if the latency is decreased, this means the performance is better. So latency is actually the delay time, shows the delay time. The amount of time spent means the delay time. So latency and performance is inversely proportional. And bandwidth is the amount of data that can be transferred over the communication channel. So it is measured in terms of frequency. So if the frequency is more, there will be if there is more bandwidth, there will be more allowed frequencies through the communication channel among the different processors. So this was all about the basics of the distributed computing, and about some terminologies that will be used throughout the course. So this was all about the introduction of distributed computing. So next lecture we will talk in more detail about the challenges of distributed computing and the purpose of distributed computing. So thank you so much for watching my video. Thank you so much.